Apologize for the fact that ASUC note-taking service did not get started at the beginning of the semester. There was a change in personnel there, and they thought they'd hired someone. They hadn't. They have now hired someone whose name is Mia, and she's right here. And she, I believe, would like to sell you on the notes, so go ahead.
Hello everyone, my name is Mia, and I'm the note-taker for this class. So you can purchase my notes for notes and notes and always the player for.
Do you know how much the subscription is?
I'm not sure, but it will be probably around like $10.
Around 30. Usually 39. Okay, there's some variation in there. Also, Mia is going to do her best to put together notes for the lectures that up till now based on the screencast, so that hopefully will work out and be available to you. So I mentioned that the screencast for lecture 2 didn't include the projector feed. It was just the audio. It turns out that was true for both lectures 1 and 2, which is frustrating. If you go to the webcast site, you'll see that lecture 3 is up there. I think by now lecture 4 is probably up there. Lectures 1 and 2 are available on the iTunes page that you can link to over on the right. So on the left, there's a list of videos that are available that doesn't include 1 and 2. And if you go over here somewhere, there's a little link. There's something that says YouTube and there's something that says iTunes. And the audios for 1 and 2 are available on iTunes for free. You have to download the iTunes player. If you haven't, I'm probably the last person on the planet who hasn't downloaded the iTunes player. So hopefully that's no problem. The midterm is next Thursday. And I'll be giving a review during the regular lecture period on Tuesday. I taught this class once before. I taught it somewhat differently last semester, but I will do my best to post problems from that exam. The exam covered some different material. I'll do what I can to practice to post practice problems, but I can't make a lot of promises on that, I'm afraid. What I would like to ask from you guys is, could you please email me at aclam.let@gmail with any questions you have, things that don't make sense, problems on the problem set that you really never got even when you looked at the solutions, specific things you'd like me to focus on during the review session. That would be very helpful to me indeed. Okay. Yes.
Do you have any idea when we're going to get back our first problem set?
I don't. When are they going to get back their first problem set? Oh, okay. Okay, so what happened with the first problem set is that we didn't have these nice signs out. That was my fault, and so they got lumped together and just divided randomly, which means that the GSIs did not wind up with their own students' papers. So you'll need to come to your GSI's office hours to pick up problem set 1, unfortunately. And from now on, starting with this problem set, you'll get them back during section. Okay, thank you very much, and I apologize for the various organizational snafus as we get the class off the ground at the beginning of the semester. Okay, any other questions about the exam, the review, anything else? Okay, today, so we have spent we're moving on. We're going to start talking about expected utility theory, which is a big chunk of what we call the standard model. And then we're going to talk about an alternative behavioral theory called prospect theory, which is a very big chunk of psychology and economics. So just to keep us on track with the sort of arc of the semester, to some extent we're following the sort of standard curriculum of intermediate microeconomics, 100A, 101A, which begins with just a theory of consumer choice where you have two goods, there's no uncertainty, there's no future or past, there's no savings, da-da-da-da. Right, and you learn about income and substitution effects and the derivation of supply and demand curves, and one's upward sloping, one's downward sloping, and that's the law, and then you see how you can map that into a labor supply model, etc. That's where we've started, is by commenting on all of that. And the most fundamental feature of that sort of standard Hicksian consumer choice model, in the absence of uncertainty and in the absence of a future, that's to say no intertemporal component, is this assumption of rational preferences. And we've seen that go over the side of the boat already. Where we're going to go next is we're going to take that no uncertainty, no future core of consumer theory and what we've already said about it, which is this sort of reference-dependent loss aversion thing. And we're going to then import that, which is exactly what you do in 100A, into situations where there's uncertainty, right? Where you don't know whether you're not just choosing between 2 apples and 3 pears or 3 apples and 2 pears. You're choosing between, do I want to adopt this set of risks or that set of risks? Because I don't actually know what my choices will lead to. There's uncertainty in the outcomes. Beyond that, we'll then take the same chunk of consumer choice theory into what happens when some of your choices are way out in the future, what happens when some of your choices affect other people, what happens when there's strategic interaction. This is exactly what we do in standard microeconomics, and we're just going to follow that sequence along. So here we are introducing uncertainty, okay? And what you learned, I sincerely hope, in 100A, or the equivalent class that you took for intermediate micro, is the expected utility model or expected utility theory. I'm going to review that, comment, not tongue-in-cheek, but somewhat archly on the fact that that's already psychology and economics. And then we'll do what we usually do, is we'll see a series of anomalies, things that cannot be explained by the standard model that will allow us to build up an alternative model that is more psychologically realistic. And you'll be very pleased to know most of it will be quite familiar to you from what we've done in the last 2 weeks. All right, here we go. The standard model, 2 slides worth of standard model. First of all, economists always have to simplify things and put them into really dumb terms. So we're going to model any situation whatsoever that you might find yourself in that involves uncertainty as a gamble. Okay, and so the word, what happened to my animations? That's not all supposed to pop up at the same time. Did I lose all? Okay, no, I just screwed up the first slide. Okay, so this word gamble is actually a technical term. Okay, it means any situation that you might choose to put yourself in or find yourself in through no choice of your own, in which your outcomes are unknown in advance. Okay, so a gamble, like I said, is any uncertain situation, and here's what it consists of. First of all, there are various different possible states of the world. Okay, so it could be that the situation that you're going to find yourself is someone's going to flip a coin, heads you win, tails you lose. Okay, so the different states of the world are it comes up heads, it comes up tails. Or maybe you're thinking about buying insurance and you might in the future get sick, and you might not get sick, and you don't know. So those are the 2 possible states of the world. Or you might be investing in a firm and you don't know whether it's going to have high profits or low profits, and so those are the 2 possible states of the world. And we'll just simply call them state A, state B, etc. And obviously there could be far more than 2. In fact, it could be an infinite number, right? What are profits? Profits are a continuous variable that goes from negative infinity to infinity. Well, not negative infinity, but from the total assets of the firm to positive infinity. Okay. for each state of the world, there's some outcome that the consumer is going to experience. Okay? And this initially could be extremely vague and nebulous, right? Or it could be extremely concrete. So for example, if it's a flip of a coin, then the outcomes would be win a prize, don't win a prize, and the prize might be extremely concrete, $100 one way or the other. Okay? Or the outcome could be much more nebulous. Hospitalization versus no hospitalization is extreme oversimplification of the outcome you experience in the two states of the world, illness, no illness, right? Because your income might change, you might lose your sense of taste for all we know if you get very badly sick, or the medication you might the illness might be HIV, and you take a bunch of antiretrovirals, and all the fat in your body goes to one place. It's called lipodystrophy. Who knows what these outcomes might be, right? Could be extremely multidimensional, could be very vague. You get a warm sense of satisfaction from the fact that you didn't get the illness, or you get a general sense of hopelessness and malaise because you did. Could be anything. For simplicity, we're going to focus on things that we can measure in dollar outcomes. But the lessons and implications that we'll learn from our models generalize to lots of much more nebulous situations. Okay? So for now, we're going to focus on situations where the outcome can be simply measured with some variable x. So in state of the world A, there'll be xa, state of the world B, there'll be xb, etc. And then critically, there is a known probability of each state of the world unfolding. Right? So this model assumes that you don't know whether or not you're going to get sick, but you know the likelihood that you'll get sick. Okay? And we will notate those as PA, PB, etc. Now, there's a screw up in your handout. It just says PB. It should say PA or PB, etc. Okay. Like any other probabilities, they have to sum up to 1, right? The probability that you'll get sick plus the probability that you won't get sick cannot equal 2. That would be very problematic. It's, because that would suggest that both of them are guaranteed. So they have to sum up to 1. And then we have this notation. If we call the gamble G, right? The gamble is get sick, don't get sick. The gamble is the uncertain outcome that you don't know what's going to happen, that you either are going to be confronted with through no fault of your own, or that you're going to choose, right? So for example, you might face the gamble. One gamble would be get sick or don't get sick without insurance, and another gamble would be don't get sick or don't get sick with insurance, right? Or the gamble might be let somebody flip a coin and tell you whether or not you're going to get $100 or lose $100, or just ignore that joker and walk away. Flip of the coin doesn't matter for you. G, what is G? G is a vector. G is actually a matrix. It's just a mathematical object, and it is this mathematical object. It's a vector of outcomes and probabilities, which you could think of as sort of a vector of outcomes and a vector of probabilities in a matrix, if you want. Okay, so let's just say it's a vector of outcomes and probabilities, and you just sort of stack them together. The way it's usually notated, and there's variation in this, as you'll see, the paper deals with it a little bit differently, is you just put outcome for state of the world A and its probability, and then a semicolon B probability, etc. Okay. Now, in the paper that's assigned, which is prospect theory, let me say two things about that. First of all, they use the word prospect instead of the word gamble. You will also in the literature sometimes see the word lottery. These things are exactly synonymous. Okay. In prospect theory, anytime x equals 0, they just don't include it in the vector, just for simplicity. Okay, they leave out. So what you'll see is that when you see a prospect or a gamble described in the Kahneman and Tversky paper, there will be a string of outcomes with probabilities, and the probabilities won't add up to 1, and that's because they're implicitly saying the rest of the probability is on you getting 0. Okay. All right. So that's what we're talking about here is people's preferences over gambles. Okay, which gamble do you choose? Now, right? You can see that if you try to take something that was just like originally x1, x2, and try to model people's preferences over different gambles, there are ways to do that in certain situations where, like for example, I don't even want to get into it. It just turns out that this model of two different goods, like if one good is a gamble without, a health risk without insurance, and the other good is a health risk with insurance, you're going to try to draw some kind of indifference curve. It turns out that model doesn't work very well. So for example, suppose the two gambles you're asked to choose between are take a chunk of money and spend it on a vacation to Nepal, where you get to see beautiful mountains and eat delicious food, but there's a small chance that you'll be abducted by Maoist rebels. Now, actually, the Maoists are now in power, so this is a somewhat outdated example. My mother used to live in Nepal, so this is a salient example for me. Or take the same amount of money invested in the stock market for your retirement, where there's a whole just a completely different set of uncertainty. Stock market might go up, you have a nice retirement. Stock market might tank, you have a lousy retirement. What does this have to do with a vacation in Nepal and the chance of being abducted by Maoists? How do you compare these things, right? This was actually a very serious problem in economics for a long time. People wrestle with this. What the heck do we do here? If it's simple money outcomes, one of the outcomes is, would you like to have me flip a coin and either you lose money or gain money, or would you rather I just give you a certain sum of $5, right? That's relatively easy for us to conceptualize how you might compare these things, because it's money versus money, and it's, But how do we deal with this when we have to model other more complicated situations? The answer. The extremely famous and bizarrely not Nobel von Neumann and Morgenstern solved this problem in 1944. Though interestingly, and this happens a lot in sciences, Daniel Bernoulli had already solved it in 1738. And I'll tell you in a little bit why we nonetheless think of the expected utility model as being a product of von Neumann and Morgenstern in 1944. Unfortunately, neither of these things is on these spaces. They're both books. And you can't, I don't know how is it possible that a book that was first published in 1738 isn't in the public domain and therefore completely available on Google Books? I don't get that. This is why it's much better if science proceeds on the basis of journal articles, because then they're all available online. So if you become a famous economist, please don't write books. Just write articles and post them online. Here's what Bernoulli and then much later von Neumann and Morgenstern said. Okay, what's going to happen is once the state of the world is known, consumers are going to have some kind of value on that, right? They're going to be able to assign some kind of utility level to that. So and we want to sort of assume that they can predict what that will be. Okay, so this should remind you a little bit of the stuff about rational expectations about predicting the future. But let's just wave our hands at that for now and say that yeah, sure, people haven't yet experienced what it's like to test positive on HIV or to be abducted by Maoists, but we're going to just sort of assume that they can predict that. And then when they're deciding whether or not to engage in risky behavior or take a trip to Nepal, what they're going to do is they're going to weigh how they feel about the various different possibilities and weight them according to the probability that they will happen. Okay, so sorry, let me back up. So they're going to, when they get to state of the world A or B, they're going to stick the outcome XA into their utility function, their non-risky, their utility function for outcomes, not for gambles, right? The thing that we've been looking at for the last 2 weeks, right? And then they're going to sum those up, which I'll comment on in a second. But this U dot, this function, this utility function here, okay, up until now we've been writing that with a big U, right? U of say good 1, good 2, mugs, money, whatever. Now we're going to start writing it with a little u. Okay, of the same exact outcomes. Maybe in state A you get some mugs, some money, whatever. And the reason we're going to call it little u is because it's going to be nested within your larger utility function for the actual gambles themselves. Okay? And this little u, Matt Raven calls it the little u, or if you have multiple states of the world, he refers to them as the little u's, which is, I guess, something sort of parallel to mini-me, I don't know. But sometimes we'll call that the value function. That's what von Neumann and Morgenstern called it. That's what Kahneman and Tversky call it. Behavioral economists, at least around here, are fond of calling it the instantaneous utility function because we're going to be using it not only in when we're dealing with uncertainty, but also when we're dealing with multiple time periods. So it's just sort of like the once you actually get to the place where the outcome happens, whether that's a particular unknown state of the world or a particular future time period or a combination of the two, you're going to evaluate your utility in that instant. We call that the instantaneous utility function. And then ex ante, before the outcomes are known, when consumers are trying to decide which gamble they like, they're just going to sum those up in a weighted sum in which they weight each state of the world by its probability. Okay? So here, we've got a capital U. That's the utility function over gambles. And it's a weighted sum of these little u's, which are the utility function over the outcomes. I sincerely hope that for at least half of you, this is very boring because you have learned it before, but it's important that we review it. What does this theory assume about the probabilities? Okay, and the probabilities are weights in a weighted sum. What does it assume about the weighting? It first of all assumes that people know the correct probabilities. Well, we're going to address that later in the semester. That's obviously a huge and crazy assumption, but we're going to wave our hands at it for now and come back after the second midterm and look at that. What we're going to look at in, today or Thursday is that it also assumes that they use the exact probabilities to weight the different states of the world. Okay? And that's something that probably wasn't pointed out to you in 100A or 101A. Okay? And what this means, IOW stands for, in other words, it assumes what we call a linear probability weighting function. Okay, so I can rewrite this big U, this utility for a gamble, as instead of weighting by the probabilities, let me just say that there's some function that transforms probabilities into the weights that you place on the different outcomes. And we'll call that pi, because that's what Kahneman and Tversky use. So let's say that the weight, pi, that you assign to the probability of state of the world A is the weight you place on the utility that you expect to get in state of the world A, right? And so instead of automatically assuming that people weight by the probabilities, we'll let there be some function that maps from the true known probabilities that they do correctly know to the weight that they place on outcomes that have that probability. And what expected utility theory implicitly assumes is that this pi function is just the identity function, pi p equals p. That the weight you place on an outcome probability p is exactly p. Okay, so if something has a 50% chance of happening, or if there's two outcomes with 50% likelihood, and you evaluate your utility function at those two different outcomes, that you weight them exactly equally. And if one of them has just a probability of 1% and the other 99%, that you weight them accordingly, 0.01, 0.99. Okay, that's the standard model. And what I want to say about that is the usual way. This is just sort of an opinion. The usual way that this material is presented, either in classes or in books or New York Times op-ed pieces, is you present some model like this, and then you scoff at it. Okay, it's just ludicrous, and we're going to see that it is ludicrous. But I also want to say it's absolutely amazing. It's a stunning piece of math, and it's a stunning piece of formal modeling. It's an extremely parsimonious, which means not very many moving parts, elegant, mathematically tractable framework for analyzing a limitlessly variable set of different possible scenarios, uncertain scenarios. Okay, in a way that actually has a considerable amount of psychological relevance already. Before we start scoffing at it, did we run out of the handouts? Does anybody have an extra handout? Okay, that means that there are more than 6 auditors. I apologize. You have another copy. Amazing. Could we pass that down? Okay, so let me say a few things. You could very easily teach an entire class on just how amazing the standard model is, without even beginning to look at extensions of the model to try to explain anomalies, even purely rational extensions. What I want to do very briefly is just to point out the really quite considerable step towards psychological realism that this model already represents. Okay? So before Bernoulli, and the reason that Bernoulli back in 1738 first proposed this idea, even just in very general terms, is that people were trying to wrestle with the idea that what people do is that first they consider the outcomes, right? Remember, we're sort of simplifying to these being money outcomes, and then they figure out the expected value of all the different possible outcomes, right? Expected value. And then they sort of figure out how do they feel about the expected value. Right? So mathematically, that makes a certain amount of sense. If there's a 0.5 possibility that you'll get $100 and a 0.5 possibility that you'll get $150, well, on average, that's 125. How do you feel about getting 125? Because that gamble is worth, technically, sort of in financial terms, on average, $125. So, that seems like a straightforward, mathematically trackable way to go about it. It turns out that even with money outcomes, it hopelessly doesn't fit the data. And of course, it doesn't do us any good when we're trying to compare a trip to Nepal with retirement savings. But nonetheless, that's what people wrestled with for a long time. Here's what I find most sort of striking about the shift from focusing on expected value to focusing on expected utility. Okay? It's not just that it allows you to compare trips to Nepal with retirement savings, nor is it just the fact that it happens to fit the data better. It's the fact that it's actually psychologically dramatically more realistic, which I hope casual introspection will reveal. It doesn't make any sense to think, first I'm going to come up with, okay, there's 2 states of the world, one where I get HIV and one where I don't. First I'm going to average the long vector of different, like my income will go down, I'll be weaker, I'll have to take these horrible drugs, I'll have to deal with social stigma, versus I won't. I'm going to take the average of all of those things and come up with this weird sort of like Rundle-Fly average experience of being, a 5%, 95% linear mixture of having AIDS and not having AIDS. What does that even mean? And then I'm going to see how I feel about that. What does that even mean psychologically? Completely meaningless, right? What we do is we think, if we think at all, hopefully what we do is we think to ourselves, well, I know what it's like to not have HIV because I've been living that way for 42 years. Let me see if I can put myself into a scenario where I do have HIV. I know quite a lot of people who've been living with HIV, and some of them, I've known some who've died, and whatever. So I have some notion of what my life might be like. Let me try to put myself in those people's shoes and see how I would feel about it. Not a bad life, 42 years old without HIV. Pretty yucky, not the end of the world if the antiretrovirals actually work for me. Now let me take a balance of those two and see how I feel about engaging in unhealthy behavior, right? Let me see how I feel about sharing needles on the street. Psychologically, it's completely obvious that that's closer to what we do. If we think about these things at all,